In this video, we're going to be discussing a little more in detail database keys. And previously, we've talked about the two different keys that we have in a database. One's called a primary key and one's called a foreign key. And a primary key is just that unique identifier for a table. This column here must be unique. It's designated here by PRI. And if we go through all of our tables, except for the raw cable data, which we just imported, we'll probably drop that, but all of them have a primary key. Foreign keys are what relates the tables together. So if you go to relations, these are our foreign keys. To expand upon it, we've currently only seen them as one column, but they can be multiple columns. We do have one example here, one called order item, where two columns make up a primary key. And you'll see in here it says MUL for multi, but if you look down here, this is where index are shown. We'll get into indexes later. Both of these say PR primary, and there's two different columns here. What this means is the combination of these two must be unique. So if we look here, one repeats, and I'm sure if we look, 26 is going to repeat, but there's only 1 and 26 together. So it's the combination of these two columns has to be unique because it's a composite key. One of the other things to note about keys is they can be an integer, perhaps even a decimal, a varchar or a string, character string. So you'll never see them as like a text field or a large varchar or something like that. Need to be something manageable. Okay, one thing to note, and I want to touch on indexes for a moment, is that whenever you create a primary key or a foreign key, an index is created at the same time automatically. So, if we go over and look at the users table, we know that there are foreign keys on occupation ID, status ID, and user type ID. You can go to relations and see those are the three here. What you'll also see is down here, this is the index for the primary key. See that column there, user ID. There's also an index for the others. This one is an index on username. We'll come back to that a little later. But you'll see that there are indexes created on any column whenever we have a primary or a foreign key. But what an index really is just like an index in a book. If I was to hand you an encyclopedia, if you can remember those, and I said, find me the paragraph on the Revolutionary War, you can do one of two things. You can read page 1, say that's not it, and go to page 2 and read the whole page and say that's not it. And then 3 months from now, I'll see you finally reaching the R's and finding the Revolutionary War, and then you found it. But most of us know we would go to the index of the books, which is in alphabetical order. We go down to the R's, and immediately it would tell us, oh, Revolutionary War, jump to this book, this page, and we would jump there. The database works the same way. We either read the entire table, or we go to the index and then can jump to the part of the table we want. And I know most of our tables, they seem big, 175,000 users, that is a fairly big table. I've seen tables go in excess of 20 million rows and even larger. So once you start getting into the millions, speed becomes a real big issue. But don't worry about that. We're going to talk about indexes in a future video. I just want to let you know that an index is automatically created whenever you create a primary key or a foreign key. Now, inside of primary keys, there's two different types. And this is not really a setting. It's not like I can go over into structure here and find a setting for this. It's more of something theoretical or something to just kind of conceptualize. And that is whether a key is either a natural key or a surrogate key. And a natural key is something made up of real data, something that would be that you can read and then predict what the rest of the row might look like. The best example for that, over here I have like maybe first name, last name, and date of birth. If that was your primary key, I have an idea of what your first and last name was and your date of birth. But the best example I have of a natural key is this table. If I go ahead and tell you my state is FL on a form, you pretty much know that's Florida. There is an inherent meaning between these two values. However, if I go ahead and I tell you item number 10, I have no idea what it is. It happens to be Ant-Man, but it could be anything. I have no real correlation between what the item number is and the title, because the item is just an incrementing number. It's random. So any type of auto-incrementing number, some type of GU or UUID, that's going to be a surrogate. By the way, a GU or UUID is not just in databases, it's known throughout the tech community or development community. It looks something like this. It's a large alphanumeric string, which is randomly generated, composed of your date and time, as well as your MAC address and some other stuff in there. So this is guaranteed to be unique for years and years to come. They're commonly used as IDs. But again, primary keys could be a string like this, or they could be an incrementing number like this. They're still unique, therefore, and they still have the primary key next to them, therefore they are a primary key. So again, natural versus surrogate, make sure you know the difference between those two. And again, I just put some examples in the slides here, better explanations of what a natural versus surrogate could be. So here's an example. Something like an artist ID, which is randomly assigned to an artist, that's surrogate. There's no relation. It's just they typed it in, it grabbed a number, and that's your ID now. So Shakira is a 6, Madonna is an 8, and Britney Spears is an 11. By the way, this is not my iTunes library. But something like a natural key, maybe not to us, but maybe to the recording arts group, would be if we have an album title and we have a release date. Well, although this might be a natural key, it's not really a good key. And the reason is there's only 365 days in a year. So I don't think iTunes would be in business if they could only release 365 albums every year, one per day. They have hundreds of thousands of albums on there. But there may be a good way to compromise on this and maybe make a composite key. And a composite means we're going to take more than one column and combine it to make the ID, just like we did in that order item table. Here I'm going to take the release date and the artist, and now the combination of the two is unique. So now I can release one album per artist per day, as opposed to just one album per day when it was just release date. So here it's a natural versus surrogate, but the important thing to know is it's a composite key. It's composed of more than one column.